Let's go ahead and evaluate the following numbers raised to rational exponents without a calculator. And the key is in rewriting these rational exponents back into root form. So here, 25 to the 1/2, that can be written as a square root. So the denominator of the rational exponent 2 becomes the root. So I have a square root, and then it's 25 to the 1st power that goes inside of the radical. So this is essentially just the square root of 25, which is positive 5. For the second example, I have 125 raised to the 2/3. So the denominator of the rational exponent, 3, becomes the root. So this is the cube root of 125, and that would be 125 squared. But I have no idea, without a calculator, what 125 squared is. So what we can go ahead and do, and we could see it from this property up here, is I could pull that power to the outside and evaluate the radical part first. So in other words, this is the cube root of 125 all squared. And so the cube root of 125 is a value I would know. 5 cubed is 125, so the cube root of 125 is 5. And now 5 squared can be done without a calculator. That's just 25. Let's try a couple more. We'll evaluate 81 to the 3/4. So the key is in recognizing that the bottom of the fraction, 4, is the root. So this is the 4th root of 81. And then the top of the fraction, the numerator, that's going to be what the whole thing is raised to. So we're going to make the number smaller. We're going to take its 4th root, and then we're going to cube it. So the 4th root of 81 is 3, because 3 to the 4th is 81, and 3 cubed is 27. And this example here has 1,000 to the negative 1/3. Well, to deal with the negative exponent, we bring that number raised to the negative exponent to the other side of the fraction bar, and then it becomes a positive exponent. So now we don't have a negative exponent. We have 1 over 1,000 to the 1/3, which is 1 over the cube root of 1,000. So the cube root of 1,000 is 10, because 10 cubed is 1,000. So this is 1/10. Notice the answer isn't negative. That's a pretty common mistake to somehow make the answer negative when there's a negative exponent. But remember, that just brings it to the other side of the fraction bar. And now we'll simplify some expressions that are raised to rational exponents. So here, 4x all raised to the 5/2 would start out by applying the property 4 to the 5/2 times x to the 5/2. X to the 5/2 can't be simplified, but 4 to the 5/2 is the square root of 4 raised to the 5th. And then x to the 5/2, the square root of 4 is 2, so 2 to the 5th times x to the 5/2, and 2 to the 5th is 32. So 32 x to the 5/2 is the simplified answer. And finally, 27y cubed all raised to the 4/3. We'll apply the property 27 to the 4/3, y cubed to the 4/3. 27 to the 4/3 is going to be the cube root of 27 raised to the 4th. And here 4/3 and 3 multiply. So the 3's are going to cancel, and I just have y to the 4th. Now the cube root of 27 is 3. So I have 3 to the 4th, y to the 4th, or 81 y to the 4th. Most of this is really knowing those common powers and roots.